Hello, and welcome to another SLP at UCLA video. Today we'll be talking about the last little bit of part creation, which is going to capture a couple of the last little things up here on this top bar. So, first up we're going to check out the hole wizard. The hole wizard is something to quickly create holes, essentially. It can also be used to make specific screw holes if you need that and you don't want to do it yourself. So we're going to click on the hole wizard. And here's what we get. We get this whole big dialogue thing here. So we can choose really anything from these hole types. I'm just going to go with this counter bore. Right, hovering over will give you the name. Well, maybe I'll go with the countersink. And we'll reset any custom sizing values. And so a counter bore is just, or a countersink is for a flathead screw or a bolt. And instead of having to create a circle and then shooting it through the box and then creating a triangle and revolving it around the circle, as we learned in the last video, that's a possibility now. What the hole wizard will do is do it for you, right? So we're going to select a hole size, and these are standard sizes for different bolts and screws and stuff. So maybe we'll choose M10. We'll leave it in close fit, and here we can do our custom sizing. So this is the diameter of the actual through hole. So maybe we'll go like this is like 11 or something, and when I turn it to custom sizing, it'll become yellow. That's how you know it's custom. And then this is the diameter of the top of the flathead screw. So maybe this is like 15 or something. And we'll have like a 100 degree angle. And so if we do that, sorry. Oh. So we have to select the face or hole or slot position. So we're going to select the face, right? And now we can like drag this around and put it somewhere on the face. So I could do this, right? But see, it brings me to the sketch thing. So maybe I want this to be 20 up from the bottom and 25 from the side. So now I can click the check mark and it'll make the exact hole I specified really quickly with hardly any hassle. Okay, so next we're going to look at the Fillet and Chamfer tools, which are the same as in sketches. We'll check that out real quick. Fillet will make a curved surface. Chamfer will make it a flat surface. Feel free to check those out on your own. I'm not going to go much into depth on them today because we've already gone over them a little bit in the sketches. Alright, so I'm going to do a couple more things. The linear and circular pattern are the same as in sketches also, so I'm not going to show you those. Check out the sketches video, which is in the playlist in the description, if you want to go see how to do those in the sketches and then just translate that over to the linear pattern and circular pattern here. But let's make a new part so I can show you some of these guys up here in these 6. Okay, so now I'm going to show you the rib feature. The rib feature is helpful when you're trying to create supports along the corner or a edge of a part to maybe make it stronger. And so right here we have our part, and you can see I have a sketched line going from one face to another face, and that's what you're going to need for the rib feature. And so I'm going to choose the rib feature. I'm going to select sketch 3, and it's going to create these 2 yellow lines, which are parallel to this blue line. And that's just going to show you what the thickness is going to be of your rib. So let's maybe make it like 20 instead of 10, right? And it'll get farther apart. And the next thing that we're going to do is we're going to make sure that the arrow is pointing towards the corner. And right now it's not pointing towards the corner. So what we're going to do is we're going to flip material side, and now it is pointing towards the corner. And so when we click the check mark, ta-da, we get a little rib, right? And this is just going to create a little more support for our part. So now let's take a look at the shell. We're going to skip the draft, and actually we're going to skip the rapid intersect also, because they're just not really that helpful. And we'll go more in depth maybe in a later video at some point. But right now it's just not important for the basics of SolidWorks. So here we have our part that we just created, our rib. We're going to click on the shell, and what the shell does is it hollows out a part from a particular face. So if we select this bottom face, for example, we can change the parameters. So I'm just going to leave it at 1 millimeter here. And what it's going to do is it's going to hollow out the part so that there's only 1 millimeter of material everywhere. So let's click the check mark, and we can see that everywhere it's like a thin wall thing with a hollow inside. And you can see we select from, or let's evaluate, measure. We can evaluate that, and you can see it's 1 millimeter normal distance. And that's gonna be true for every two parallel faces. All right, so now we're going to take a look at the mirror function. And the mirror is really helpful when you have something like this, where it's like this complicated hexagon plus cylinder plus extrude rectangle thingy, and you wanna, you've built one, but like you don't have to do it again on the other side, right? If you want it to be symmetrical. So let's go here to the mirror. We can choose a mirror face / plane, and we're going to choose this this plane here in the middle. We're going to choose features to mirror. I'm going to come down here. We're going to choose the cut, or we're going to choose all of these actually. 1, 2, 3. You can control click on them. I don't actually think, yeah. So it won't let you do just it won't let you just keep clicking. So you have to control click for those. So we can, here we have our preview over here in the yellow, so we can click the check mark, and now we have the same shape on the other side. And now you may be wondering how I got this plane, and there was a plane in the last video and an axis in the last video. So the way I did that was with reference geometry, and that's this little pull down menu here. And in this reference geometry, we can do a bunch of things. So the main one you're going to be using is the plane or the axis. So we're going to look at those and maybe some other things. But first off is the plane. And the plane is pretty straightforward. We're going to choose a reference. So like maybe you want a plane that's a little ways up this, but there's no, one of the origin planes like this isn't exactly where you want it. So you click on a face, choose the offset. So maybe this is like 20 or something. That's still too high, so maybe we'll make it 12. And now I can choose to sketch on this plane here. Some other things you can do. The way I got this plane was by choosing 2 faces instead of just 1 face. So if you choose 1, 2 faces, it automatically detects that you want a mid-plane. And this is just the plane at the very center of these 2 faces. Pretty straightforward again. That's really all we have to go through right now. If you want to experiment, feel free. Again, it's always up to you. But let's take a look at the axis. For this, it's also pretty simple. We choose a circular face. We get an axis in the middle of the circular face. We can do other, things, right? This will give us an axis that's across this plane and perpendicular, right? So this is exactly there. We can do 2 points, so maybe we want this point and this point, and it'll give us access through there. Really helpful if you're trying to make specific lines that you wouldn't otherwise be able to get, or maybe like rotations around that specific angle, which is not something you'd ever be able to get just from like a sketch, right? Maybe we'll check out the center of mass here, which is pretty helpful if you're trying to make like a real life part. It'll show you exactly where you are, and we'll talk about how to like create materials and apply those to the parts you make in the next video. Coordinate system, again, pretty simple. Just click on a face, define your axes. So this is x-axis, y-axis, and then z-axis is derived because of the right-hand rule. So now I have a new coordinate system. But yeah, these will all help more in more advanced part creation. That should be it for today. I hope you guys learned something, and check out more of our stuff on the channel. And I hope you all have a great day.